Okay, so we are here. We have this problem, y equals 5t to the power -3 plus 7t to the power -8. So we need to find y prime and y double prime and y triple prime. So we need to find anyway y prime, right? Need to find y double prime and y triple prime. So let's find y double prime, y prime first. Y prime is d over dt 5 t to the power -3 plus 7 t to the power 8 third. Right? Now we can use our laws of derivatives. 5 constant multiple rule d over dt t to the power -3 plus 7 d over dt t to the power -8 over 3. Right? 5. Most of the time in homework and quizzes, and also in the exam, what I saw, what I observed is that most of you are pretty reluctant, or maybe you think that you may spend more time on writing those operators. Just give it up, writing. And also, you try to do things in a one shot. Right? You are just learning. I mean, you don't want to be really quick. I mean, that's the unnecessary thing. I really want you to write these operators. You need to understand how these things operate on addition, over subtraction, over multiplication, over many different operations. Right? And also when you write the limits, most of you don't write limit. Limit x goes to that part is completely ignored. That's not a good sign. If you want to learn this, you have to follow these things. It takes a little bit of time, yes, I agree. But you are still learning. Okay. So, and you have to go through most of you have to go through another 2 calculus courses. It's the first one. Okay, so you learn right, this course right, it will be immensely beneficial for the other courses. You miss things here, you're going to miss more in the next courses. You're going to face more difficulties in the next courses. So when you learn this, learn it right. Okay, it goes a long way. A small thing, it goes a long way. So this have this type of like this, d over dx x to the power n is equal to n times x to the power n minus 1. Right? So we can write the similar way, -3 t to the power -3 minus 1 plus 7 -8 over 3, right? T to the power 8 over -8 over 3 minus 1. Right? So we have y prime is -15 t to the power -4 plus sorry, it's going to be negative minus 7 times 8 is a 56 divided by 3 t to the power -11 over 3. Right? That's your y prime. And then you want to find y double prime. You're going to do the same thing again. D over dt -15 times t to the power -4 minus 56 over 3 t to the power -11 over 3. Now I can distribute this. I can take 15 out, negative 15 d over dt, t to the power negative 4 minus 56 over 3, because it's a constant. You can take that out of the differential operator. T over d over dt, t to the power negative 11 over 3. Does that make sense? Now you're gonna derivate this, negative 15 times negative 4, t to the power negative 4 minus 1, 4 minus 1 minus 56 over 3, negative 11 over 3, t to the power negative 11 over 3 minus 1. From this, we get 15 times 4 is 60, t to the power negative 5 minus 11 times 56. We get 6, the 6 and 55, 61 over 9. T to the power negative 14 over 3. Is that correct for y double prime? Y double prime? Is that the answer you got? Okay, good. Yeah. So now we can do the next one. Y triple prime is d over, oh, this is positive, right? This should be positive. Should be positive because this is negative and this is minus sign. So d over dt, let me know if I make a mistake, okay? I may make mistakes. And I'm going like this. Keep your attention here, right? And then you can do the addition rule again, or summation rule. You can put 60 out of that, and then you can take d over dt, t to the power negative 5, my plus 616 over 9, d over dt, t to the power 14, negative 14 over 3, right? So you get here 60 times negative 5, t to the power negative 6, because negative 5 minus 1 is negative 6. And here you get 616 over 9 times negative 14 over 3. This is t to the power negative 17 over 3. Okay. So this is easy. This is 300 negative t to the power negative 6, and this is negative. This is not divisible. This is, you have to find 600. So it's positive. 616 times 14 divided by 27. T to the power negative 17 over 3. So I have to multiply that and find the answer. What is that? 6,160 plus another 2,464. 660, 2,464, 4, 2, 6, 8, 8,624. Right? You can divide it by 20. Might not be divisible. You get it. Yeah. It's a decimal, yeah. So you can leave it like that, or you can put it. It's 8,624. That should be minus, yes. That should be minus, yeah. That's good. That's why triple prime. that make sense now? Yeah, good. Which was the difficult part in that problem? This is any other questions? 67. Okay, so it is a chain rule, right? This is problem 67. Mistake. You need to find. Okay, find the derivative. You are given y equals 2 times e to the power 3x plus 3 times e to the power negative 2 negative 2x to the power 4. You can do this in two ways. One is you can directly use the chain rule by taking that function inside the parentheses as u. And the other one is you can use the power rule, right? You can use the power rule for a function. Remember that we learned something like this: d over dx gx to the power n is equal to n times g of x to the power n minus 1 times g prime of x. We learned something like that, remember? Now my gx or g of x here is the function inside that parenthesis. Okay, so if I do that, right? If I do that, that's actually this is a result of chain rule. This is a result of chain rule, nothing else. Same thing. So if you remember chain rule, you can do a lot of things. If you know how to apply the chain rule, that's it. You can do a lot of things. That's why I always ask you to make a concept map. What are the concepts that you learn? And how do you build the one concept from the other? That's a good way of learning. So you take this as g of x. And your y prime is equal to, right, n times, or that 4 times, right? 4 times g of x is that inside 2 to the power 2 e to the power 3x plus 3 e to the power negative 2x. N is 4 minus 1, right? And then I need d over dx 2 times e to the power 3x plus 3 times e to the power negative 2x. Right? I need that. And then you have you can leave that like that. 2 to the power 2 times e to the power 3x plus 3 times e to the power negative 2x cubed, right? And then you can put the summation rule, right? You can put summation rule d over dx 2 times e to the power 3x plus d over dx 3 times e to the power negative 2x. And here it's 4 times 2 e to the power 3x plus 3 e to the power negative 2x cubed. This is 2 e to the power 3x. Now you can put the chain rule here, right? You can put the chain rule. So if you put d over you can take this as u, right? right? Or we can use the power rule, doesn't matter, anything. So chain rule, if you use the chain rule here, right? Well, you cannot use the power rule, but you can put the chain rule. 2d over du e to the power u times du over dx plus, right? You can take 3 out here, and you can also again do this as negative 2x as b. You can take negative 2x as b, right? Then you're going to do what? T over dv e to the power v, right? Times dv over dx. And I'm going to write, does that make sense? How I get v and u, right? So my assumption is what I did was I took, let u equals 3x and v equals negative 2x. Why did I do that? Can anybody say why did I do that? Why I did that? Can anybody say why I did that? What is the reason that I took 3x equal u and negative 2x equal v? What is the reason? Tell me answer. You know it. What are we trying to do here? Can anybody answer? Can anybody give any clue? It doesn't matter, get wrong, but it's okay. I need some answer for that. Why is that? Why is this change? Can we directly find the derivative of e to the power 3x? Can we do that? Do we know any equation for doing that?
Still, e.
I didn't get you what?
D over dx of e of x.
Yeah.
To dx.
Yes. E of x is, yes, ex. But what about e of 3x? E to the power 3x. So if he says, what Doug says is this: d over dx e to the power x, e to the power ex, e to the power x is e to the power x. Right? That we know, but we don't know this, right? D over dx e to the power 3 of x. 3x. Right? But we can make it look like this by putting 3x equal u. Right? And then we have to do the chain rule. Because now this becomes a function of u, but u is a function of x. Right? So it's a composite function. Once you see a composite function, you can apply that chain rule. Does that make sense? Because we know the derivative of this function, this one, but we don't know this. We don't know. Does that make sense? So this is what I want you to visualize. Anytime you see something like that, how do you make a composite function so that I can use chain rule? You need to identify what is the derivative that you already know, and then you can make your function look like one of these. Does that make sense? If it doesn't make sense, let me know. I can explain it in a different way. Yes, Jason. Can I explain differently? Yes. So do you understand that we know this? D over dx e to the power x, e to the power x. But the difficulty is now, what we need to find is this, d over dx e to the power 3x, right? It is difficult to find that because 3x is e to the power x times e to the power x times e to the power x, right? But what I can do is, if I had something like v or u instead of 3x here, right? That means what I did was I took u as equal 3x. Now what is u is a function of x, right? And now what is y? If this is y, y equals e to the power 3x. Now y is a function of u, right? You can put as gu, right? Right? But u is a function of fx, so it's g of f of x. What is that? What is a composite function, right? So I made it like that. So that's another thing, okay? So now what I did was I put u equals 3x. So I see that, okay, d over dx e to the power q. Now I have e to the power u, but I need to find d over dx e to the power u. But my variable is u. Now I cannot directly do that. So what I would do is I say, okay, d over du e to the power u, I can find that. And to make it equal to this d over dx, what I do is I put d over dx here and du over dx here. So now you can see that du cancel to du and this becomes d over dx. I mean, it doesn't do that, but it seems like that, right? So you can put du over dx here because you can find du over dx, u is a function of x. Does that make sense? No? So that's how we do. Now, if we do a different problem, you can do it in a different way, right? So now here, x plus 3 e to the power 2x cube. This is 2. This is e to the power u plus du over d, sorry, plus, times du over dx is 3, right? Plus 3 times dv over d over dv, ev is e to the power v times negative 2, right? So you have 4 times 2 e to the power 3x plus 3 times e to the power negative 2x cube. This is 6 times e to the power, u is 3x, right? 3x minus 6 to the power e to the power negative 2x. So you can take 6 as a constant, and then you can simplify it a little bit if you want to. Otherwise, you can leave it like that. Does that make sense? Now, without using this power rule, you can use the chain rule, maybe another time, once again here at the beginning, and then you can get the same answer. Right? Does that make sense? Now, if I were to use the chain rule, now I'll show you that one as well. Did you copy this down? Did you get the answer? Okay. So if you want to use the chain rule for the same problem, we have y equals 2 times e to the power 3x plus 3 times e to the power negative 2x to the power 4. So if I want to change, if I want to use a chain rule straight, what would I do? Which function should I name as u? The function in the 2e, right? So this one, right? We call as u, right? We call as u. Then what is it? Why is this easy? So you have u to the power 4, right? Now you can directly find dy over dx, right, is equal to d over du, u to the power 4 times du over dx, right? So now you can do 4 times u to the power 3, right, times what is du d over dx? U is what? 2 times e to the power 3x plus 3 times e to the power negative 2x. So now I've got to find the derivative of that part, which is what we did earlier. Same thing. Okay. Now you can use the rules. We know this is 4 u to the u cube, 2 times d over dx e to the power 3x plus 3 times d over dx e to the power negative 2x. Right? So we did that part. So I'm not going to repeat it. What we did in the other problem is the same from here onwards. So you take u and v, or you can take any other names, any other letters for that, and you can do the same thing and get the answer. So you can apply chain rule different many times, as many times you want, to solve any problem. Any other problems you want me to talk about? 86, the 7.3, 86. Okay. A 2005 study by Fisheries Research Services in Aberdeen, Scotland, suggests that average length of the species, it's called Atlantic herring, as a function of age t in years can be modeled by L of t. So this is the function, 86 LT is 32 1 minus e to the power negative 0.37 t centimeters for 0 to t 13. So t in years, right? Yeah, from 0th year to 13th year. That's the length of Atlantic herring. How fast is the average length changing at age t equals 6 years? First question is, how fast the average length changes, changing at age t equals 6. Part B, at what age is the average length changing at a rate of 5 centimeters per year? At what age the average length changing at a rate of 5 centimeters? Okay. So how fast it's changing is what does it ask you for you to find the mathematical? Ask you to find the rate of change, right? Rate of change at a point. What does it mean in terms of mathematics? L prime. L prime. What did you say? What did you say? Prime? Or prime? L prime. L prime. Right? So that means the first derivative. What does first derivative tell you? We talked about different things that the first derivative tells you, right? The slope of the tangent line at a particular point, right? If you substitute some value of t or x to the function or derivative, right? You can find the functional change, and then you can substitute value, you get the slope of the tangent line. That will tell you how fast that changes. See, I brought up an example of that car, right? Distance versus time. Now, what's the first derivative of distance versus time curve? What's the first derivative of distance in time? Or displacement in respect to time? What's the first derivative? Velocity. That's the rate of change of displacement. How fast the displacement change with time. Now, what does it ask? How fast the length changes, right? How fast is length changing with respect to time at a certain point, right? So this is an example I took because it's related to biology, right? So this is how species length scales and even some factors related to human are calculated. They are exponential functions. So now what do we need to find? We need to find d over dt of LT, which is called L prime t, right? It's 32, so we can find d over dt 32 times 1 minus e to the power negative 0.37 t, right? And this is what? 32 times d over dt 1 minus d over dt e to the power negative 0.37 t. Now I can take 0.37 t as what? Negative 0.37 t as u. I can take that as u, right? Then I can apply 32. This is 0, right? The first one is 0. It's a constant, right? Minus, right? What? D over du e to the power u times d over dt, right? U. Chain rule, right? You have 32. This is negative d over du, eu is eu, e to the power u, right? And then you have d over dt, negative 0.37 t. Does that make sense? So you have what? 32 negative times e to the power u means u is 0.37 t. This is, you take d over dt, what is the answer? For the second, this part. What is the derivative of negative 0.37 t? Negative 0.37. Very good. Negative 0.37. Right? That's the derivative. Now you can multiply 0.37 times 32. It becomes positive, right? 32 times 0.37 e to the power negative 0.37 t. This is d over dt lt. Now what we need to find is d over dt lt at t equals 6, or also called L prime 6, which is 32 times 0.37 e to the power negative 0.37 t is 6. Now, if you solve this, you can get a value for that. Okay. Use your calculator to do that. Now, the second question, does that make sense? Is the first answer make sense? So we need to find the year, right? Year at which at what age the average length changing at a rate of 5 centimeters per year. So this rate is given as 5 centimeters per year. Okay, centimeters per year. So now we found this one, right? L prime t. What is our L prime t? L prime t is 32 times 0.37 e to the power 0.37 negative 0.37 t. So it's 32 times 0.37 e to the power negative 0.37 t. So that's our L prime t. Now, at some point, it should be equal to what? 5. At some point, it should be equal to 5. Now we need to find what is t when it is equal to 5. Does that make sense? That's what it says. This gives you what? This gives you the rate of change of length. At time equals t. Now we want to find t when it is equal to 5. Does that make sense? Okay, so how do I find that? Now I can solve this. E to the power negative 0.37 t is equal to 5 divided by 32 times 0.37, right? You get some number for this one. And then you take natural logarithm, the both sides. or you can write like this. So you can write 1 over e to the power 0.37t is equal to, right, what? 32 times 0.37 over 5. Does that make sense? Oh, no. Should be other way. My mistake. 5 over 32 times 0.37. Right? Because the negative power is 1 over, right? Right? Does that make sense? And then what? E to the power 0.37t is equal to, I can cross multiply, right? Is equal to 32 times 1.37 divided by 5. Right? Does that make sense? If it doesn't make sense, let me know. It's like this. X to the power -1 is equal to 1 over 5. So what is x equal to? What is x equal to? 5. Same thing. Right? So now you can get the natural logarithm without any problem. Now probably you had a negative sign in front of that. It's kind of problematic, but now you can take it. I mean, it's not problematic anyway, but yes, you can deal with the negative sign. But I just wanted to not to have that negative sign. But if you take natural log with them, right? Then what is this one? 0.37 0.37t natural log of e equals natural log of 32 times 0.375. So what is natural log of e? What is natural log of e? 1. Very good. Natural log of e is equal to 1. Just like log 10 is 10 of 10 is equal to 1. Right? Log a of a equal to 1. Natural log of e equal to 1. So this is 0.37t is equal to natural log of 32 times 0.37 divided by 5. Right? So t is equal to 1 over 0.37, 32 times 0.37 divided, sorry, natural log. You take natural log. Ln that's your t. Does that make sense? That's how you solve that problem. So what was the difficult part for you in that problem, Joe? Well, how to do it? So which part you didn't understand? What? So one of the key things to understand in that problem is that now these are the problems that you may see when you're taking other classes. Okay. You will not be given a problem just to asking you to derivate this. just to asking you to find the rate of this or something like that. You will be getting problems like this in the future. Right? That's what you have to train for. So you have to connect the actual application problems to what you learn. That's why I gave that kind of problem. I'm going to give you similar problems later in chapter 4 a lot. Just to train you for that. Okay? Is that good? Or bad? You don't want that? You don't want more problems like that? Huh? But if you want to do, if you want to make sense other classes that you are going to take in your courses, this is what you need to train for, right? Yes, you're not going to get a degree in mathematics, right? Degree in calculus or something like that. Yes. So you have to thinking about these kind of problems that are really applications. Don't worry, we can train ourselves. Don't worry. I started like that, just like you. It's a little bit of time you need. It's a little bit of time and commitment to do that. Okay. Any other questions? No questions? Done? Number 61 or what? 61. Okay. Y is equal cosine 1 plus x divided by 1 plus cosine x. Find the derivative. So what point do you think that it is difficult, this problem? What is the difficulty you face? You didn't try it. Where do you get stuck? That's what I want to learn. So that I can help. You read what? Quotient rule. Yeah, you can do quotient rule. That's a good start. Let's do the quotient rule. Let's do the quotient rule. So you do dy over dx, right? So you can write d in derivative, you can write quotient rule like this, right? 1 plus cosine x squared, right? And then we derive the numerator first, right? And we have the denominator 1 plus cosine x and the derivative of the numerator cosine 1 plus x, right? Minus, this is a minus sign. And then you do numerator, right? You find that, write the numerator first, cosine 1 plus x and the derivative of the denominator. Right. Then what did you do? You gave up. Why did you give up? Okay. So now if you have time, what would you do? So what do we need to do next? Simple, right? Now break it down. You when you see a lot of terms in this expression, you might get scared. Don't be scared. Break it down to simple parts. So how do I break down? You want to find the derivative of this part and the derivative of this part. That's it. The rest is fine, right? But the other things do not change. Only thing is that you need to find d over dx cosine 1 plus x and d over dx 1 plus cosine x. That's it. So which one is easy to find? Can anybody tell me out of those two? 1 plus cosine x. Why is that? Right. So it's like, so let's see now. How do I find the first one? Let's keep this difficult one for later. So now if you think this is difficult, let's keep that. Cosine 1 plus x, right? Minus cosine 1 plus x. Now, this is a summation, right? This is a summation. So I can put d over dx 1 plus d over dx cosine x. Is that difficult? So probably sometimes you have many terms. When you have many terms in the expression, you might get scared. Oh, there's a lot of expression. I don't want to do that. Don't think like that. It's going to be easy. Okay. So now this can be taken care of, right? So now what is the derivative of this one? D over dx 1? 0. What is the derivative of this one? D over dx cosine x? Negative sine x. Very good. Negative sine x. Now we know the answers for those. Now that part is done. Right? And then the next part. Cosine 1 plus x. Do we know the derivative for cosine 1 plus x? What do we know? It's a composite function, it's an inside function, right? So if you had something like cosine x, you can do that. So instead of x, I put u. 1 plus x is equal to u. Now it's a chain rule. This is what? This is u. Right? As soon as you put that as u, you can put 1 plus cosine x. Sorry. And this is, you're going to do the chain rule d over du cosine u times d over dx. Now u is what? 1 plus x minus cosine 1 plus x, and this is only negative what? Negative sine x. Right? Divided by 1 plus cosine x squared. Right? And then you have 1 plus cosine x d over du cosine u. What is the answer? Negative? Negative sine what? U. Good. Negative sine u. And then for this one, it's again summation. D over dx 1 is 0. D over dx x is 1. So it's just 1. Right? Does that make sense? And then minus cosine 1 plus x. Oh, then you have, this is sine x, right? So you can put, this is positive, right? Sine x. And then you have 1 plus cosine x squared. So this is negative sine u. Negative sine u is 1 plus negative sine 1 plus x. Right? So you have negative sine 1 plus x, 1 plus cosine x plus cosine 1 plus x sine x divided by 1 plus cosine x squared. That's it. Yeah. Can you solve any further? Probably you should be able to, but I don't really want you to. You can actually use some trigonometric identities, like you see that cosine 1 plus x sine x, and then you see sine 1 plus x cosine x. You can write it as sine. You can write these two terms, right? You can write negative sine 1 plus x cosine x plus cosine 1 plus x sine x plus, sorry, minus sine 1 plus x divided by 1 plus cosine x squared. And then you can write these two terms, sine a plus a minus b. So a is you can write x minus 1 plus x. This sine this is what sine negative sine 1. So this is sine 1 minus sine 1 plus x divided by 1 plus. That's the furthest that I can go. I mean, I can probably use some other trigonometric identities to solve that sine 1 and sine 1 plus x. But that's unnecessary, I guess. So I would stop here. Does that make sense? Any other things? So my advice is not to intimidated by the number of terms that you have in the expression. You always can simplify it step by step. So if you know the basics of what we have talked about so far, you should be able to do anything. Okay, so if you don't have any questions, I will stop here, this discussion of problems, and then we're going to do the quiz. And then we're going to start today's lesson.